Welcome to another session. Before proceeding, please you have to subscribe, turn on notification, share and like it. But if there is any comment, please you may leave your comment there and you will pass through. Yes, let's proceed to question and discussion. Let's see our first question. What is the value of k if three numbers k plus 3, 2k plus 6 and 8 are consecutive terms of arithmetic progression? That this given number or sequence is consecutive, that after one terms followed by another terms, so it is a consecutive. Next one after one is next one, right? Okay, let's see a solution. Acha tuangalie solution. Given a first term, because it's consecutive, ni term zinazofuatana, so the first term is k plus 3. A second term is 2k plus 6, and the third term is 3. That is given, no confusion there, don't mix things. So because our series is in arithmetic progression, we have to find the common difference. Common difference is we get common difference by subtracting the first term from second term and third term and the second term from the third term. You have to subtract in order to get the common difference. Ili upate common difference lazima utoe termu ya pili toa termu ya kwanza, au termu ya tatu toa termu ya pili. Utapata common differences zinazofanana. So when you take the second term minus the first term, or the third term minus the second term, you get the same common difference. Let's see. Let's second term minus the first term, call it equation number 1. Also it's the same. The same who use that to find a common difference is the same who use this one to get the same common difference. To get common. Call it equation number 2. Kwa hiyo atakayechukua equation ya kwanza au atakayechukua ya pili, wote watapata common difference inayofanana. So because this is two things which are equal, just equate these two equation, right? Yes, equation number 1 and equation number 2. Equation number 1 is a2, or the second term and the first term is equal to a3 minus the a2, or a third term minus the second term, right? Yes, after that substitute the value of a1, a2 and a3 in the given equation. Baada pale substitute samani za a1 uliyopewa first term, termu ya kwanza, termu ya pili na termu tatu ulizopewa. It will be 2k plus 6 as the second term minus the first term is k plus 3 is equal to 8 minus 2k plus 6. Open bracket by multiplying with the negative, alright? It will be 2k plus 6 minus k minus 3 is equal to 8 minus 2k minus 6. That is all about. So after that, correct the right term, and after correcting right term, it will be 2k, it will be k plus 3. K plus 3, when you take 2k minus k, you get k. When you take 6 minus 3, you get 3. So 2k plus 3 is equal to 2 minus 2k, right? So after that, those who coefficient which have k, you must take it to its side. Let's take it to left hand side, and the variable or constant take it in the constant take it in right hand side, as you see in your screen. It will be 3k is equal to -1. After 2 minus 3, you get -1, and k plus 2 we get 3. Divided by 3 both sides, because we are told to find k, not 3k. You get -1 over 3. Hiyo ndio thamani yetu. Yes, let's another question. Given p plus 3, p plus 8 and p plus 18 are the third term, fourth term, fifth term of geometric progression, respectively, alright? Respectively. Find the value of p and the common difference Find the value of p and the common difference. You already given that data. So you have a third term, fourth term, fifth term. Umepewa term ya 3, ya 4 na ya 5. What is required? Kinachotakiwa ni nini? Kutafuta thamani ya p na common ratio. Right? Let's start. Let's see. Solution. Given G3, that the third term of geometric progression is p plus 3. Fourth term, or G4, is equal to p plus 8, and the fifth term is p plus 18. So because this is a geometric progression, we require, or we will find the common ratio. We must find the common ratio. So when you take G4 divided by G3, the same who take G5 divided by G4. When you find the common ratio, mtu atakayechukua G4 gawanya kwa G3 atapata common ratio ile, na atakayechukua G5 gawanya kwa G4 atakapata ile. Let's see. Yes. Okay, G4 over G3, the same who take G5 over G4, as I said before. Let's proceed. Just substitute there. The issue remains easy to substitute. Wherever there is G4, write a value of G4. Wherever there is G3, write the value of G3. Wherever there is G5, the same applying, write a value of G5, as you see there. So it will be p plus 8 over p plus 3 is equal to p plus 8, p plus 8, p plus 18 over p plus 8. So cross multiplication. After cross multiplication, you get that bracket p plus 8 bracket p plus 8, right, is equal to p plus 3 times p plus 18, as you see. So after multiplying, you get p square. At the left hand side, you get p square plus 16p plus 64 is equal. The right hand side, after multiplying, you get p square plus 21p plus 54, right? So correct right term. The term which are similar, just correct it to each side, right? Yes, you find that p squared will cancel, and you take the terms which are similar to each side. It means the terms which have the similar variable. So we take 54 to left hand side, as you see there, and 16 to right hand side of equal sign. So we get 64 minus 54, you get 10, and the 21p minus 16p, you get 5, as you see there. So divide by 5 both sides, you get p is equal to 10 over 5 is equal to 2, right? Yes. Therefore p is equal to 2. We found that our p is equal to 2. After that, what next? The next is to find the common ratio, because we know that G4 over G3 is a common ratio, or G5 over G4 is a common ratio. Just take only one function there. So we will take G4 over G3. Tutachukua function moja tu pale juu ili kutafuta common ratio, but we already know the value of p. Just the issue is to substitute. You see, the common ratio is denoted by r. G4 over G3, just substitute the value of G4 and the value of GP, or fourth term and the third term, and you find that the value of GP is p plus 8 over p plus 3. Just we already got the value of p. Substitute wherever there is p, write 2. So it will be 2 plus 8 over 2 plus 3. It will be 10 over 5, because we are told to find the common ratio. That is our end of common ratio. Welcome again.